Welcome to a lesson with Dr. Powell. Let's see if this series converges or diverges by using an integral test. So we're going to be comparing this to an integral, and we simply just think of this as being from 2 to infinity of 1 over n natural log n. Now, of course, this is absolute convergence. We have to check that this is always going to be positive, and it is. As n goes from 2 to infinity, this guy is positive. It's also decreasing um, because as n gets bigger, these guys' denominators get bigger, and so we're going to be decreasing. So it matches the criterion that we are after. So we can just simply look at this and think about the integral. Now, also with, okay, so with this, and maybe what we do is, think about, we could think of n as being continuous variable, but let's use x's. So we have x natural log x dx, and we can integrate this. Also keep in mind this is absolute convergence, so that if I had put a -1 to the end, then this will say, then this integral will only say not what the convergence of this would be, but this integral would tell us about the absolute convergence of the series when we take absolute values and end up getting 1 over n natural log n. So that's what this would say. So this is really, just remember that this is an absolute value convergence test. Okay, so as we move along, let's think about what needs to be done. The derivative of natural log x is 1 over x. So this looks like a nice u substitution problem. So we can think, we could think of this right here as being u, replacing dx with du, but divided by the derivative of u, which is 1 over x. Notice the 1 over x in the denominator and this x here in the denominator, they cancel. So we're simply left with du over u and change bounds. Okay, so it looks like when when x is 2, u is natural log of 2. When x goes off to infinity, saying the limit, natural log of really big is infinite as well. So we end up getting this. We can take an antiderivative, which we end up getting as natural log of u. Now u is natural log of u. Let's just do that. And we're going natural log of 2 and a limit as u goes to infinity. Now, in taking a look at this, we will notice, so we end up getting, as u goes off to infinity, this is infinite. So this diverges. So since this integral diverges, that'll tell us that this series also diverges, absolutely. And since it's already positive, it does diverge. So this series diverges based upon this integral test for convergence divergence. Thanks for watching.